Okay, so welcome to our Kent County Master Gardener Workshop. I'm Debbie Nicole. I am teaching today and I'm also the workshop chairperson. So we're going to talk about a few different things. We're going to get some soil basics and we're going to talk about testing. And we're going to talk about what to do and not to do to help your soil. So first I'll talk about what is soil. This is a definition from the Soil Science Society of America. So basically, there's a lot of different definitions out there. It's basically the layer on the surface of the earth that is a place for plants to grow, gives them a place to grow. They grow in the soil. There's a lot more to it than that, of course. You know, a lot of things live in the soil, you know, that we will also talk about. So that is on your crossword puzzle. That's the easy one. Okay, so what is soil made of? Soil is mostly, it's half solid and the other half of it is just the spaces in between those solids. So the solids are made up of minerals. And the minerals can be clay, silt, and sand. And the minerals come from rock. Everything started from rock. The rock broke down over time through water, freezing, cracking, animals digging through it or burrowing through it. So the minerals came from rock. And depending on the kind of rock you start with, is going to affect the kind of minerals that are in your soil. Okay, so sand was mostly came from quartz. As you can tell, it kind of looks like that. And the other ones, silt and clay, they came from other kinds of minerals. I wrote that down somewhere. Anyway, so then a small part of the solids is also the organic material that's in your soil. It seems like it's a lot more than that, but it's really only maybe around 5%, can vary between 2 to 10 usually, of organic material in your soil. The rest of it, those spaces between all the particles, can be either filled with water or air. Okay, so this diagram here is like half and half, but what do you think is going to happen in a drought? The water goes down and the air goes up. What's going to happen after a heavy rain? Yeah, the water will go up and the air will go down. So this part, the water and air can vary. Okay, but it's important to have both because plant roots to grow, they need both air and water to grow. That's why they suffer in a drought, but they also suffer in a flood because there's very few plants that can live without air getting to the roots. There are some, but usually things that grow in like bogs and stuff, usually some of their roots will be above the water, and that's how they get their oxygen. Soil texture. So we talked about the minerals. The minerals can be either clay, silt, or sand. So I have kind of a little model here to show a little bit of proportion. So a sand particle is really big. So if you think of this whole globe, and if you guys can see this at home, as a piece of sand, like an enlarged piece of sand. Clay particles are the smallest, and silt is somewhere in between. So I put some little clay pebbles inside here, which really isn't what clay particles look like. They're kind of more flat in general. So clay particles are tiny, tiny, tiny compared to a sand particle. And clay particles are stickier. They hold more water, sometimes too much water if you have too much clay. And sand, you know, the water drains through really quickly because the particles are so big, the spaces between are bigger and they don't hold the water. So there's a test you can do to find out how much clay you have. There's it's called a field test. So you can take a ball of soil and squeeze it into a ball. And if you kind of push it through your fingers until it makes a ribbon, if it makes a ribbon that's like at least 3 inches long, that means it has a lot of clay. If it just falls apart, that means it has more sand. So that's just a little kind of a qualitative test. It doesn't tell you exactly what the percentage is. There are tests you can do in a lab where you can get the exact percentage. So a perfect soil, if you look at this triangle, which doesn't exist in nature, a perfect soil would be a perfect loam. The loam would be about 40% sand, 40% silt, and 20% clay. Since clay is so much more dense and the particles are so small, they say a little clay goes a long way. So a loam would be that. A lot of the soil will be clay loam in Delaware. You may have more, since we have more sand in our soil in general, especially as you get closer to the beach, your soil may be more like a sandy loam or a sandy clay loam. So there's no such thing as pure clay, pure sand, or pure silt in real life. They're all a mixture. Okay, briefly I want to talk about soil organisms, because these are really important to know that these things are living in your soil. They have a lot of really good things that they do to actually improve your soil. So when you think about the bigger organisms like beetles, worms, and the larvae, and the little arthropods like the pill bugs and things like that that live in your soil, they do some really important things. So they tunnel through your soil to aerate it, allow paths for air to get through, also paths for the roots of plants to grow. If your soil is too hard, compacted, they help with that. They also, what do worms do? They provide fertilize. Yes, they provide castings. They eat, and they poop, and the poop is fertilizer for your soil. So they're important. So a lot of the organisms that you find in the soil, they provide nutrients in some way. So nematodes are really cool. Those are little worms. We're going to talk about those in a minute more because those are like one of my favorite soil organisms. Fungi are really, really important. Fungi are important for breaking down like the leaf. That leaf mold is made by fungi. So that's a good fertilizer. Fungi also, there's certain kinds that can attach to plant roots and they actually grow out and extend the plant roots. So they're like little shuttles. They take water and minerals and they actually transfer them to the plant. So there's a lot of benefits of fungi. There's also bad fungi, like the kind that harm your plants, but there's a lot more good fungi than bad fungi. Bacteria and viruses. Bacteria is what makes up most of the organisms in your soil. And you can have, like, if you took a teaspoon of soil, it has like 10,000 bacteria in just a little tiny bit. So the bacteria, there can be beneficial bacteria and there can be non-beneficial bacteria, but the beneficial types outnumber the bad types. So it's good to have soil bacteria in general. And then all of these things, there's a dog-eat-dog world out there under the soil. They all eat each other. So there's that too. So when they eat each other, then they also fertilize your soil. Okay, I want to talk about nematodes real quick. So these are really cool things that live in your soil. They're really, really tiny. They have to be seen with a microscope. You can't see them with the naked eye. There's about, I think about 1,000 in a teaspoon. And these things, these little guys, and I have a video here. Hopefully it's going to work for us. So this is a nematode video taken with a microscope. And if you look really closely and carefully, you can actually see those little black dots. Those are bacteria that it's eating. So it consumes the bacteria. And they can eat 5,000 bacteria in a minute. Most of them are good. Some of them are bad, like root knot nematodes, if you've ever heard of those, if you ever grow root vegetables, these things the root knot ones can damage it. But something that's really good at taking care of nematodes is there's a certain kind of fungi that feeds off of nematodes. So it'll actually saw a video of this too. You look on YouTube, there's a video. The fungi can grab the nematode and trap it, and it breaks it up into pieces and it consumes it. So that's something that fungi eats. It says the dog-eat-dog world down there. Okay, so those are some of the components of soil. Now we're going to get into soil testing. So this, I want to show you my tool. This is a soil testing tool. You don't have to use this. You can use an ordinary trowel. I really love this because it has little serrated edge there, and you can dig it into the soil. And for convenience, I label mine with a Sharpie about the depths and measure the depths so that I can get the soil to the right depth. So that's just something I do. Because it's hard to see once you stick it in the ground, you don't know how deep you've gotten. And your soil test report, when you fill out the paperwork, it'll ask you what was the depth of the soil. So it depends on where you're getting the soil from, how deep they want it. Like if you're using a vegetable garden, you go deeper. If you're doing your lawn, you don't have to go as deep. So it'll tell you on the instructions in your soil test report. So did anybody bring their soil test with them? No. You have yours? Okay. So if you look at it when we go over this, if you have any questions, you can ask. If not, I can look at it with you at the end of class if you want, if you have any specific questions after we go through this. So if you haven't had your soils tested, it's really good to do because you don't know if your soil is good or not without getting it tested. And the test can't tell you everything, but it can tell you a lot. So the soil test, like I said before, it just went up recently. It's $17 and now it's $22.50. So you guys at home, if you need to get a soil test kit, they have them available here at Pardee. You just come to the office and ask for a soil test kit. And then you take it home, fill it up with your soil by the directions included. And then the best thing to do is to bring it back here and drop it off. There's a place to drop it off. Otherwise, you have to pay postage to mail soil. So I would advise bringing it here to drop it off.
That's a question.
Yes,
sure. Curiosity with the testing. If you are testing for a lawn, say, and you've got a pretty good sized lawn, do you just test in one spot, or do you take soil from all around that yard?
Good question, and that's part of the instructions that come with it. Okay. So if you're testing your lawn, you want to kind of get an average of the lawn because you want to, if you're going to have to fertilize or treat or put lime, you're going to put it everywhere. You're not going to just put it in spots. So what you do, and the instructions will tell you to do, is to take your sample from a variety of locations, put it into a bucket, a clean bucket together, and mix it up. And then you mix it up, and then you take the size. The kit has a bag that has a little line on it. You have to fill it. Make sure you fill it up enough, because if you don't fill it enough, they won't have enough to do all the tests. So there's a line in there that says fill to this line, fill to that line. There's a little plastic bag, fill it, tie it up, and that's when you drop it off. But the soil, good question. Anywhere you do it, even if it's not your lawn, if it's a vegetable garden, you should still take it from a variety of spots, because even things they're testing for pH. And your pH over there could be different than your pH over here. So, it's not an exact science if you need it in a specific spot. I have raised beds. So if I want to test just one of my raised beds, for example, I have blueberries, and blueberries like more acidic soil. So I've been putting sulfur on that soil to make it more acidic. So when I'm testing my soil, I'm just going to test it out of that raised bed that I've been treating to make sure it's actually doing what I think it's doing. But I still will take it around the raised bed and mix them together.
Question, I haven't opened just to see, but do they test for more than just pH?
Yes. Okay. Yeah, we're going to go over all the stuff that's cut. You're going to know way more than you ever want or need to know.
Okay, all right, thank you.
And if you remember it, you remember it, and you might not remember it because, to be honest, there's a lot of chemistry in here. So if you don't have a fairly decent understanding of chemistry, it's not going to mean a lot. But at least you'll know what to look for on the test. So I'm going to tell you what to look for. Even if you don't really totally understand what it means, that's fine. Do we have any chemists in here? My dad was a chemist, so if I get too chemistry, just tell me to stop. Okay, say stop it, tone it down. Okay, so we're going to start with the soil test. This is a copy. It's not my soil test. This is one that was given to me to use as an example. So I want to point some stuff out. So this is the result that you'll get back after you send it in and wait, 4 to 6 weeks or so, depending on the time of year and how busy they are. And you get this back. They will email it to you and they will mail it to you. So you get it both ways. Usually get it faster by email, like as soon as they get it done. So these are the things they test
Sorry.
for.
New, they no longer will mail you your soil test results unless you pay extra.
Oh, really?
Yes,
Okay,
it
thank
just
you.
started, it's brand new.
Okay, that's something new.
So they email them?
They will email it to you.
Okay, okay. Good to know. Thank you, Megan. So the soil test report, these are the areas. So the first part up here, you've got pH, which we talked about. Then you've got your macronutrients right here. These are your macronutrients. These phosphorus, potassium, magnesium, and calcium are the most important ones that are shown on the test, okay? And this little graph over here shows you the fertility index. This is just numbers that they came up with, some kind of index. So you can see it goes from 0 to 100. And what you're aiming for is that green area, the optimum. Okay, so that's going to tell you, like if you look at this one, my calcium was way up there in optimum. My pH might be showing a little low, a little bit to the low, but I'm going to tell you something about that in a second here. And then the rest of them look pretty good. The problem is sometimes you get excessive. Mine in my garden says excessive for some things, and a lot of people in Delaware will have excessive for phosphorus. Okay, it's the soil, and it has to do with it being a lot of stuff being farmed for many years, and the phosphorus builds up. It doesn't, more gets put in than gets used by plants. And we'll talk about that a little bit when we start talking about fertilizers. This thing right here, this is some more information that you may or may not care about. Organic matter, you're going to be interested in. Some of the rest of this stuff, these right here, boron, manganese, zinc, and sulfur are considered micronutrients. So your soil just needs little bits of that. Doesn't need near as much as it needs of the other things. And the thing about this is, unless your report tells you to add it, you shouldn't add it because too much is toxic to plants. So this is just, these are micronutrients, and like I said, as long as they don't tell you anything about it, you're good. So just rely on what they tell you. And then we'll go over the rest of these numbers here. But these are where more of the chemistry kicks in. And pH is a little bit too. So what I want to mention about pH though is you see this says crop vegetable garden. When you turn in your soil test report, you're going to tell them what you're growing. So if it's for your lawn, you're going to put that on the form because the pH for the lawn that they recommend is a lot higher than it would be for a vegetable garden. So if I put lawn on here, they would tell me that this was low. They would tell me I needed to add lime. So it depends on what you're growing. That's why it's really important. If you're growing blueberries, it needs to be a lower pH. So if I was growing blueberries, they would tell me I needed to lower this by adding sulfur, which is why I do that. Okay, so it's very important on your report to put in what's growing in that soil that you're testing. Because otherwise you might not get the right answers. Okay, this part down here, they're telling me to put nitrogen on my garden. Okay, this is something they tell everybody. You see nitrogen on this soil test report anywhere?
No.
We're going to get into that, but they don't test for nitrogen. So they're telling you this just because they tell that to everybody, because all plants need nitrogen. Okay, so I had people come to me and say, oh, I got my soil test back report and they told me I needed, my garden doesn't have enough nitrogen. And I said, no, that's not what they're telling you, because they didn't test your nitrogen. And I'm going to tell you why in a minute. Okay, so the first thing we're going to talk about is the pH. This one is a pH of 6.1. So what is pH exactly? We were just talking earlier about testing hot tub water.
Between your acids and the bases that are in your soil.
So the pH scale goes everywhere from 0 to 14. But 0 would be like, battery acid, burning your hands off. And 14 would be like bleach. So those are just the extremes. Almost everything in real life is somewhere in between. So neutral is 7. I found this graphic. I don't totally agree with these numbers here. So the pH of most soils, it says is between 5.5 and 8. There's a lot of them that are lower than that. There's some that are more acidic. Around here, you're not going to get AIDS. That would be something that you might find out in the desert or out west in drier climates. So the healthy range for most life, I would expand that a little bit. So 6.8 is kind of high. A lot of vegetables like things, more closer to 6.5. So for soil, I think according to what I learned, 6.5 is pretty good. Some plants do need like more acidic soil, in which case you may have to amend your soils. That's why you need a soil test report, because you don't want to add lime or sulfur, which are ways to change your pH if you don't need to change it. So you can do this. You can test this. You can buy kit. Try to test this at home. This is a lot more accurate. The University of Delaware one. So blueberries, hydrangeas, azaleas, camellias, all those like more acidic soil. And you can fertilize them with an acid plant food of some sort to make them happy. Okay, so since I grow vegetables, and you grow vegetables, this is just a little side note. So this is the pH that your vegetables mostly like. As you can see, stuff like rhubarb likes a lower pH, and spinach, all the way up to spinach, likes a higher pH. So these are kind of put in order. But as you can see, most of them, your soil has a pH of 6.5. It's pretty much got everything covered. So if you want to grow vegetables, a good goal is to get your pH around 6.5. If you do need to adjust your pH, here's a couple of recommendations. These are not the only choices. These are more recommended for organic gardening. So if your pH is too high, like if you're growing blueberries and you want to drop that pH to like 5 or even 4.8 for your blueberries, you can add elemental sulfur. It's just little yellow flat disc, looks like, and you just sprinkle them on your soil, and it slowly lowers the pH. This doesn't happen instantly. It takes years to change it. So sulfur will lower the pH. Aluminum will also lower the pH, but you gotta be careful with aluminum because if you add too much, it's toxic to plants too. Sulfur will not hurt your plants, but aluminum, if you get too much, you don't know, you're not careful. A lot of people use aluminum sulfate on hydrangeas to make them the blue color. But if you add too much, it's like I said, it's toxic to your plants. If you need to raise the pH, and this is something they'll tell you on the soil test, and we'll get into how they know how much to tell you, how much lime to add from your soil test. So if you need to raise your pH, if your pH is too low, if it's a lawn, a lot of people put lime on their lawn because their pH may be like 6 and they need to get it up closer to 7. So they'll tell you to add lime. There's a couple different kinds of lime. Calcitic limestone is calcium based. Okay, but there's also one that's called dolomite lime, and the dolomite lime has calcium and magnesium in that. So if your soil test report shows your magnesium is low, you may want to add dolomite instead of calcium-based lime. Okay, you can buy either of these at stores. So but your soil test report will tell you if you need to add lime, it'll tell you how much to add. So you don't have to figure that out for yourself. So now we're going to talk about the macronutrients. First, like I said, phosphorus, potassium, magnesium, and calcium are the macronutrients. They are the ones you need the most of. And then there are these down here, which are the micronutrients. And like I said, the micronutrients, I wouldn't do anything with that information unless they tell you, if you're growing corn needs boron, they may tell you you need to add something with boron, which can be done with boric acid or, regular old 20 multein borax that they sell at the grocery store. Those are boron based, but you just have to be really careful because a little too much and you kill everything. So I don't add any of those things. these nutrients are things that your plants need. This is your NPK, nitrogen, phosphorus, potassium, okay? Your soil test will give you how much potassium and how much phosphorus are in your soil, as well as all these other things. What happens is these are not pure in your soil. They are ions. So in other words, they're things that are dissolved in the water. Once they're dissolved in the water, then the plants can pick them up. So they have to be dissolved in the water. Just something dry put on there isn't good. That's why when you fertilize your plants, they'll tell you to water it because it needs to dissolve. So the perfect NPK that plants can use is actually 716. So the N is the nitrogen, the P is the phosphorus, and the K is the potassium. So you notice I said 716. So phosphorus is what they need the least of. So phosphorus you have to be very careful with because it's really easy to have too much in your soil, which will result in a lot of pollution, and it can also harm plants and the microorganisms. So you don't really want to add phosphorus unless it's really, really low, because the plants don't need as much of it as they need of the other things. Okay. So here's another little bit more science. Try to keep it simple. Your soil test can't test for nitrogen because there's a cycle that happens continuously. So you can take a sample, and before that sample even gets to the lab, the nitrogen will be gone. So it can't test for that. It's always changing. So there's nitrogen. The air that we breathe out here is 70% nitrogen. So it's nitrogen all around us. But that kind of nitrogen can't be used by plants. Something has to happen to it to be used by plants. It can be changed by lightning. Lightning will change that into a form that plants can use, like ammonia. The really important thing is there are these bacteria that live in the soil. They're really important that they can actually take nitrogen from the air and change it into NH3, which is ammonia that the plants can use. Okay. So the plants will use ammonia and nitrates. So those are what's shown at the bottom here. And then what happens is there's some other bacteria that change that back, and they change it back into nitrogen gas. So it goes through this whole cycle. It goes from nitrogen gas to forms the plants can use and back into nitrogen. So that's why they don't test for it. At Delaware, there are ways to test for it, which is very complicated, which involves freezing it and getting it to the place while it's still frozen so they can immediately see what was in there because it's going to change. If you freeze it, it doesn't change as much. So that's why it's not on your soil test report.
You have a summer storm with lightning and of course water. Like when you watch corn, it looks like it grew a foot.
Really?
Ever notice that? Like
I didn't.
I live out in the country.
Yeah.
So it grows very quickly after a storm, and I'm thinking lightning is probably a good part of that.
It might be helping with nitrogen.
Yeah.
So. I've honestly have never watched corn grow. So.
You live out there, you'll see
Yeah.
the difference in the height. It'll happen rapidly.
So here are some symptoms that your plants might show if they are nutrient deficient, or in some cases, if they have too much. So this is not the only thing you should use to determine this, because it could be, if your leaves turn purple, it doesn't necessarily mean that they have a phosphorus deficiency. It could be something else. It could have been they got too cold. Could have been they got dried out. It could be a lot of other things. So these are just more clues than absolute rules. Okay. So another symptom that you see a lot of this is this interveinal yellowing, which they call chlorosis. So how this happens is the veins of the leaves will still be green, but the parts in between the leaves, the leaf, in between the veins will start turning yellow. And as you can see, that's a symptom of several different deficiencies. Okay. And then sometimes when you have too much, it's toxic. So nitrogen You can tell if it's deficient. This is pretty good because the leaves at the bottom start turning yellow and falling off, and the ones at the top will grow and be green. So because it's sending all that to the new leaves, to the new growth. If you have too much nitrogen, you get excessive growth. They grow too much green stuff. And this also will make your blooms and your flowers suffer because it'll spend all its energy going into the green leaves and you won't get enough for the blooms. So that's why you want to be really careful. Don't do too much. It's just as bad to do too much as it is not enough.
So Debbie, you're saying on that picture of that leaf, it's the potassium, magnesium, and calcium?
Well, I'm just trying to show you what chlorosis looks like.
Okay.
And it's a symptom of magnesium. I believe it's also a symptom of iron. You can have that, and also manganese. So it's a symptom of more than one thing. So you can't really say, oh, this is definitely a magnesium deficiency because it could be something else. But it definitely needs nutrients if it's doing that. Some kind of nutrients. So sulfur is kind of the opposite of nitrogen. When you need nitrogen, the bottom leaves are going to turn yellow. When you need sulfur, the new leaves will turn yellow. So it's the opposite. Just because the leaves are turning yellow doesn't mean it needs nitrogen. It depends on where those leaves are. Okay, so this is just kind of a guideline. This is not a hard and fast rule. It just means that something is wrong. Fixing it is not always that easy. So as far as fertilizers go, I like organic fertilizers, but nitrogen is nitrogen is nitrogen. So if you want to use an inorganic fertilizer, it's the same chemical. It's the same chemical. It's just that there's more of it. So some of the chemical fertilizers, the synthetic ones, will just have higher percentages. So the first number here is the percent of nitrogen. The middle number is not technically, the middle and last number are technically the percent of a compound that contains those. It's not pure phosphorus or pure potassium. So the number you see there is actually a little bit less than that. So this is just a guideline so you can compare them. I like organic fertilizers because it's almost impossible to burn your plants with them because the numbers are so low. They also contain carbon. If they're, by definition, organic means they contain carbon, and everything needs carbon. You know, we're mostly made out of carbon. So everything needs carbon, but that also, since they're organic, they're a lot slower to break down, which is also what keeps them from burning your plants. So they break down really slowly. The carbon attracts a lot of those microorganisms which eat them and break them down. So that's what happens. Compost at the bottom, I have a little star by it because depending on, if you're making homemade compost, those numbers can vary widely depending on what you're putting into your compost. So there's not a hard and fast rule. Does anybody here do compost?
Yeah, I have a question.
Yeah.
My compost doesn't do well. And it turns into balls. So this year I'm thinking about doing compost tea. Have you heard of that? Where you soak it in water and then water it. And should I test the water before I do that?
What water are you using?
Well, just regular water.
Like
but
tap water?
Yeah.
I don't like using tap water on plants because they put, especially if it's city water, they put things in
I
it.
could get water out of my rain barrel. but
Yeah,
I don't
that
know
would
what's
probably
in
be
that
better.
either. That's what I'm saying. Should I test the water?
Rainwater is actually has a pH of about 5.5. So it's a little more acidic than say like distilled water, pure water, because as it comes through the atmosphere, it collects the carbon that's in the atmosphere and it produces a carbonic acid, which makes it more acidic than pure water. So kind of cool. So actually rainwater is less acidic than it used to be back when we had more air pollution. So with more air pollution, there was a lot more chemicals in the air and they got in the rainwater and made, what they called acid rain. But we get a lot less of that now since we cleaned up the air. So it's interesting. It's also complicated. Everything changes all the time.
Debbie? What water do you use if you don't use
the tap water? I mean, what are your vegetables?
What I use, my water, I have an irrigation system, so the water comes straight out of the well. So it comes straight from the groundwater. And I have a spigot in my garden, and that's what I use to water my garden. So it doesn't come through the water softener and all that kind of stuff, because the water softener adds salt and things like that. Salt is not good for your soil. We'll talk about that later. So anyway, I just want to throw this out there. You don't have to use organic. This is just something for you to look at. These are some of the things that I've used. And you can see, I have used green sand to add potassium. So,
I haven't heard of it.
yeah, you don't have to. You just, you don't have to use organic. You really don't.
No, I mean, I try to use organic, but I'm just saying I never heard of green sand.
Oh, it comes from like kelp or something. I don't know. It comes from something out of the sea. I know.
Okay.
I don't remember exactly. Okay, so back to the soil test report. The organic matter. Organic matter is just, it's really important to have organic matter in your soil. If you have no organic matter, your soil is basically dead and useless. I mean, it's like all minerals. So the organic matter is very important. As you can see on this particular soil test, it's 3.2. We said that, back to that chart at the beginning, that it's about 5% of your soil, so it can vary. This one is a little on the low side for a vegetable garden, in my opinion. This would be fine for your lawn. But for a vegetable garden, I think that's a little low. And you can see at the top of the chart, it's just barely the edge of optimum. What is organic matter? So it's the part of the soil that comes from, it's, carbon based. It's part of the soil that comes from things that are either alive now or dead or something that was produced, like manure and urine, or also organic matter that are in your soil from all those organisms. And they're all in ways they're good for your plants. They provide nutrients. So about 5% of your soil is organic matter, like we said. Organic matter is really like, it feeds all those microorganisms and things that live in your soil. That's what they eat. That's what they need to eat. Whether they're eating other living things, or they're eating leaves, or they're eating, anything that's decomposing in your garden. I recently learned that, so organic matter can have this wide range. It can be from things that are alive or just recently dead, like green stuff, fresh stuff. It can go all the way to humus. And humus is when it's completely degraded. And by the time it's completely degraded into humus, it doesn't have a lot of nutrition left for your plants. So all the parts in between of being fresh green till it's done are when it's good for your plants. Mm-hmm. So they used to say, don't put fresh organic stuff into your garden, but it turns out that you can, as long as you keep it moderate, because that's feeding all those microbes. They're like, smorgasbord, they're all munching away at all that stuff. And that's what's in your compost. It's all the microbes that are in your compost that are breaking all that down. But it takes a long time. Yeah, it can take like 5 years for a compost to go from fresh stuff to humus.
So should your compost be fresh? In other words, let's say you have a compost pile and you hadn't put it on the garden for a couple of years.
Yeah, you can put it on.
So it's still good even though it's a couple of years old.
Yeah, it's just more decomposed than fresh. And they tell you, like when you do composting, they tell you, feel it, and it should feel like soil and all that. And it's actually somewhere in between fresh and its final stages at that point.
And how do you apply it to your garden?
How do I put it on the surface?
Okay.
Because I don't like, we'll get into that. I don't like tilling more than I need to, but I put it on the surface. And then we'll talk about cover crops too, which is also.
Is that another thing you would wait until it's going to rain or water can you just throw it on? Like this summer, we had no rain.
Yeah. Well, the rain and the water will make it go down
Right,
faster.
so it's like,
but-
you put your compost on, and you know it's going to rain.
You can, yeah. Yeah, but it's not gonna hurt to put it on if it's not, it'll just dry out. But the microorganisms will attack it and they'll start eating it and they break it down. They take all the biggest pieces and they eat them, they break them down to smaller molecules. And then they keep going until you get down to the bacteria that break it down into the very smallest molecules. And it ends up just being carbon, hydrogen, and oxygen in the end. So as it breaks down completely.
Hey, Debbie, just a real quick question on the fresh kind of compost. Can you just like I hear things like eggshells, coffee
Mhm.
grinds. Can you just go and take those and like crunch up your eggshells, your unused ones, and just sprinkle them on your garden beds and the coffee
You can,
grinds?
it'll still take them a long time to break down.
Yeah, so I figure like if you're digging, you're kind of moving it in there.
Yeah, be careful with the coffee grounds because they're acidic. So
Okay.
if your soil's already too acidic, you may be making it even more acidic when you add those. So you have to always be just less is better than more most of the time. Yes.
Is that the same with, eggshells, for calcium? And then maybe bananas for potassium? Do we have to be careful in how much of those we add?
So there was actually a little thing in this book that I was reading that was about, they were talking about bananas. And they said, some people like stick a banana in their garden but what it's doing is the plants aren't using the banana. The microbes and the organisms will start eating the banana and they will break it down to a form eventually that the plants can use. So in that way it's helpful, but it's not instantly helping your plants. Okay, so your ranges of organic matter, I want to mention that more again is not always better. If you get too much organic matter, like higher than maybe 10% or so, your soil is going to be too soggy. Because organic matter helps it hold more water. It's going to be too soggy. It's going to hold more water, and it's going to be bad for your plants because they're not going to get enough air to the roots. Because remember, there's that balance between air and water. So you don't want. I had somebody. People think that more is better. It's not. And so you don't want to add it if you don't need it. That's why they put it on your soil test. So things that are like, about the peat bogs. You know what a peat bog is? Yeah. So I just have to do my little sustainability speech here. So peat bogs exist in, mostly areas that are colder and wetter, like up in Canada, they have a lot of peat bogs. So what this is like really almost no minerals. It's almost like all organic matter. It's these layers. And the reason that it's there for so long is because the decomposition doesn't happen as fast when it's a cold, wet environment. So you end up with these layers of organic matter that are just peat. And so it takes it a long time to break down. So when I was a kid, my dad always went out and bought bags of peat moss when we planted trees and everything too. Well, it turns out that over time, they've harvested this and harvested it and harvested it from places like Canada and North in Europe and places that those it gets all used up. And since it takes forever for it to regenerate, to form again, they're running out, and it's bad for the environment there. So instead of using peat as organic matter or as putting it in my hydroponic systems or something like that, because it's basically non-soil, it's just organic matter, it doesn't have the minerals. I use things like coconut coir, fiber, things like that. It's a good replacement for peat. So that's just my little sustainability speech.
Now, I was wondering the same thing about green sand, because
Yeah.
I don't like when we take all the stuff out of the ocean.
Yeah.
For us, it's not.
I know. I don't know that they take a lot of it or anything. I don't know that much about it. So
Well-
that would be something we would have to research. Yeah, everything is a balance, It's like take a little, leave a little, So when organic matter gets completely decomposed, that's when they call it humus. So my mom always thought it was something that you ate with chips. Now let's get into this part. So, this is the real chemistry part. So if you don't understand what I'm saying, just tell me to, shut up and move on or whatever. So the first number here is buffer pH. The highest this number can be is 8. So this is just something that they use in the lab to calculate how much lime to put on your soil. So it's just a measure of how resistant your soil is to changing the pH. Okay? So if it's higher number means it's more resistant, it's going to take more lime. If that number is lower, they're going to tell you to use less lime. So they actually have these tables. So you're looking at your goal pH. So if your goal pH is 6.5, you use the 6.5 table. You look at your current pH, and you on the one direction, and the buffer pH is in the other direction. Where they meet in the middle is going to tell them how much lime that you need to put on your soil. Okay, so that's a way of them telling you how much lime. You don't need to know what that number means because they're going to tell you based on the tables, which you're not looking at. Okay, so the highest that number can be is 8. That's the top number. So if your soil, if you don't need to change the pH, then you don't need, that's irrelevant. If your pH is fine, if you get your soil tested and it's 6.5 for your vegetable garden, it's perfect. You don't need to add lime, then that number doesn't mean anything because you're not going to be changing your pH. It only happens when you need to change it. So the next number, percent phosphorus saturation. So too much phosphorus is bad, like we said before. So this number tells you basically how much phosphorus your soil is holding onto. And if it gets up into like 25, that's bad. You don't want it holding that. You need to keep it lower. Lower is better. Okay? Does that make sense? That's really all you need to know for that.
Mine's 47.
47? Yeah. And yours probably says excessive. On your test, does it say excessive?
Yeah.
Yeah. So it's the thing about phosphorus is you can't take it out. But what you need to make sure that you do is not add any fertilizers that contain phosphorus. So look for something with a 0 in the middle when you look for fertilizers. You don't want to add phosphorus because you're wasting not only your money, but you're contributing to pollution in the environment by doing that. Did you have a question?
I don't want to know how you would amend that, but you just answered that.
Yeah, you know what? Any kind of soil, the best thing to do, as long as it doesn't have too much organic matter, is add organic matter. That's a solution to a lot of things, believe it or not. But just you don't want to add any that has phosphorus in it. So how do you know if your homemade compost has phosphorus in it? See, you can get that tested, but there's so many variables in all of this stuff. Depending on your pH of the soil, you need different amounts of nutrients. If your pH that's why we like to keep the pH somewhere in the middle, because if it's too high, it causes a problem for some nutrients. If it's too low, it causes a problem for different nutrients. So as long as you keep it in the middle, you're usually good. And that's not usually a problem. You're not going to go out and get your soil test back and find out your pH of your soil is 10. It's just not gonna happen. I mean, you could find that your pH is 4, in which case they'll probably tell you to add lime because you want to get it up a little bit. Okay, the next number is like one of the hardest ones to understand. The CEC stands for cation exchange capacity. So just to get into a little bit of chemistry, I'm going to go back to my model here. Think about surface area. You remember your geometry class? You know what surface area is? My husband said, tell him that you're going to wrap this up in wrapping paper, and that's going to represent the surface area. I said, that's kind of a good idea. So if you were to wrap this whole ball in wrapping paper, you would use a certain amount of paper, and that would be the surface area. But if you look inside here, there's all these little balls which represent the clay. When they're actually there would be a lot more. So a lot more, these are kind of big for clay. They would be smaller than this. But I didn't have something smaller to use. So if you were to take all of these little balls out and wrap them up in wrapping paper individually, would you use more or less wrapping paper than you would to wrap this outside of this? More. Okay, that's because all of these particles have a greater surface area. Okay, so going back to cation exchange capacity, all of these things here, phosphorus, well, especially potassium, magnesium, and calcium. Look at those. Those are positively charged ions when they're dissolved in the soil. They have a plus charge. Okay, soil, especially clay, has a negative charge. So what's happening is on the sides, the surfaces of this clay, they're holding these little plus ones are attached to the little negative soil, just like a magnet. You know, if you take a magnet and you put a plus into a minus in, they stick together, right? So all of these things are sticking to the negatively charged soil. Okay, but there's this really cool thing that can happen is to make it, plants can't use it while it's sticking to the soil. It has to come loose and get into the water and get to the plant. So the cation exchange capacity means how easily that soil can release one of these good things that your plants need and trade it with something like a hydrogen that comes from the water, because a hydrogen is also a +1. So they'll swap. So this is a measurement of how easily your soil will do that. Clays will do it more easily because they have more surface area. Okay, they have more surface area, so they have more things stuck to them. So they'll have a higher CEC. So what's your CEC on yours?
17.
17. See, that's higher than this one, so that's better. That means that your soil has more of these nutrients available for your plants. Okay? Does that make sense?
Something good.
Yeah. So I would want to get this, we usually say, well, it's on the next page. I usually say like between 10 and 40 would be good. You know, some really, really clay soils could have like maybe up to 100, but then your soil is probably too clay for other reasons because it's probably holding too much water. So if your number is there is like say from 10 to 40, that's probably pretty good. If it's more to the 40 side, that probably means you have a more clay soil because it has the ability to hold more of those things. Percent base saturation, I don't even know why they put this on here. That's just a measure of how much of those exchange sites, the surface area of these, is taken up by those good things. So higher is better. So this one's pretty good. 78.6% of the things that are stuck on the soil are your nutrients. So I'm not really sure why they put this on your soil test here because it's just, they don't really, even on your soil test report, they don't explain these things. So I only know all these things because I took a class myself, which was so awesome. It was really cool. Okay, so that was basically most of what you need to know on your soil test report. If you do have copies and you have other questions, I'll be happy to look at it for you. So what do you want your soil test report to say? Well, a lot of it's going to depend. Your pH, you know, if you get anything between 5.5 and 8, then it's usually okay. You want it somewhere in the middle. 6.5, I would say, was about perfect. Unless it's for a lawn. For its lawn, you might want it closer to 7. Phosphorus, this all comes from that fertility index that's on there. So this is all the optimum range. Any numbers in that are in the optimum range. 75 is right in the middle of the optimum range. And it's just an index. It doesn't really mean anything. It's just a number. It's not like a measure of quantity of something. So any of the micronutrients, like I said before, they're going to tell you if you have a problem. You tell them what you're growing, and they'll look at your pH, and they'll use those things to know if you need more of any of the micronutrients, but not very likely. In Delaware, you don't usually need any of those things in our soil. Organic matter, usually between 3 to 6%. You get up higher than 6, more into the 10 range, you're going to get soggy soil. Cutting exchange capacity, like I said before, how easily your soil can release those nutrients to the plants. Somewhere around 10 to 40 is good. Your buffer pH, like I said, 8 is the highest that you can get. And then your phosphorus saturation, try to keep it under 25 or try to look for it to be under 25. If it's too high, you definitely do not want to add more. Your plants won't be able to use it. Okay, so now we're going to get into the part where we talk about how to take care of your soil. So I picked out some things that I think are the most important things you can do to keep your soil healthy and in its best shape. So cover crops, I've done a whole presentation on cover crops. It's one of my favorites. I use cover crops everywhere. So the last thing you want to do is keep your soil bare. Bare soil is not good. It loses a lot. It can get eroded. A lot of things can happen. You don't want to keep it bare. You want to keep it covered with something growing or some kind of mulch or something at all times, if possible. Compaction is really bad because if you think back to our original slide where we had the spaces where you had the water and the air, what happens if your soil is compacted? What happens to those spaces? Yeah, there's less of them, so that's less opportunity for water and less opportunity for air and less opportunity for the roots to grow because they can't grow through really compacted soil. So we're going to talk about how to prevent compacting your soil. Salt. I don't know how many times I've gone online and places like Facebook and these gardening things where people don't know what they're talking about and they say, oh, kill your weeds by dumping salt on them. You do not want to put salt on your soil. Salt is terrible for your soil. So don't do that. If you're tilling, try to go to no-till or reduce minimal tilling. Sometimes you have to just loosen up the soil a little bit, but you don't want to overdo it because it's really bad for your soil. I'll talk about that later. Of course, avoid pesticides because we have all those things living in the soil and you dump a whole bunch of pesticides on them, you kill all those things, and then not everything. Bacteria can survive a lot of that stuff actually, but a lot of these other organisms, if they die, they're not burrowing in your soil. They're not doing a lot of things that they need to be doing. Overwatering is bad for your soil. Again, we'll get into that more, but if you think back at that picture we had originally, you keep constantly putting water. I have people in my neighborhood that have their sprinklers running like 3 or 4 times a day in the summer, and your soil gets too soggy and it's not good for it. Your plants can't get air to their roots. And we'll talk and other things too that I'll talk about in a minute. And then you always hear this nowadays, leave the leaves, right? Mm-hmm. Leaves are organic matter and they're actually really, really good for your soil. So first of all, I want to talk about cover crops. There's 3 basic categories that, you can think about. The first thing is the legumes. And these things are really, really cool. This is crimson clover in this picture. Peas, beans, alfalfa, those are all legumes. And what that means is they have roots, and the roots form nodules. And the nodules contain a special bacteria. Special's one of many kinds, but a specialized bacteria that can actually take that nitrogen that's in the air and change it and feed it right to the plant, right at the roots. So nothing is lost, nothing is wasted. Like if you put nitrogen fertilizers on your yard and they just rains and washes them away, you lose it all. But this is a way, if you have legumes planted, it's a way that gets nitrogen directly to the plant roots. So I plant crimson clover. I have some growing in my garden right now. And when I'm ready to plant, cut it down. And then you can either work those cuttings into the soil lightly, or I usually just let them lay on the surface of the soil. And they'll break down, the microbes will break it down, all those organisms, and it will fertilize your soil. So this is like the best kind of cover crop you can have. This is bacon radishes, which a lot of the farmers here that I've talked to, they'll use those in their fields during the winter season. And what they're good for is reducing compaction, because these things, these roots can get huge. I've seen pictures of a kid holding it up and it's like, you know, that long.
Wow.
What they'll do is if you have compacted soil, those things will break it up. Those root things will break it up. So those are really good for that. And then the last kind, grasses, they're really good for keeping your soil from eroding. Because, you know, when your soil is left bare, you have wind, you have water rushing over it, all those kind of things that can just wash your soil away. And then you end up with, you know, either bad subsoil or, you know, happens a lot in places where there's a lot of erosion. Yes.
Winnetor has an area of it in their parking lot where they planted some radishes,
Oh, yeah.
and it's breaking up the asphalt.
Oh, yeah. Yeah. Another thing that's good at breaking up asphalt is wiregrass. That's what I was gonna tell you. Wiregrass goes right through the asphalt. That's what I'd recommend planting it.
Crimson clover you mentioned.
Yes.
Is that an annual plant?
It is technically, but if it doesn't get cold enough, it'll come back. I planted a lot of cover crops and they didn't die. So, sometimes if it gets cold enough, it'll kill them. And if it doesn't get cold enough, they'll keep growing. So
And Debbie, when did you plant them?
in the fall, I planted them like in September.
Okay.
So they're covering, when my gardens are not being used to grow, you know, tomatoes or cucumbers or whatever, there have something in the raised beds to keep them covered. And then when it's time for me to plant something else, they're gone. I remove them. You can remove them. I mean, you can pull them up, but then you lose that organic matter that you could put in there. So, so those are just an example of that. So, the next thing, that was the next one. Yeah. Okay. The next thing let's talk about is compaction. And this is just an example of a graphic that I found that kind of shows what compaction can do to your soil. So basically, the fatter something is, the less it's going to compact the soil because that weight's spread out over a larger area. So you see the fat tire over there, it has a larger footprint, so it's not compacting. This is like a picture of how deeply it's compacting the soil. Okay, so a fatter tire doesn't compact, so it's better not to drive on your soil at all. But the wider tire spreads that weight out. So you can see the little plant root there is able to grow deeper into the soil because it's not as compacted. So the middle one is somewhere in between, and then the narrow tire compacts the soil all the way down here to this level, so the plant can't grow because the soil is too compacted. So those radishes would help break it up. You can reduce compaction by aerating your soil. Plug aerators are much better than the other ones. Plugs, the ones that pull the little plugs out, those are fine. But the other kind, the kind with the spikes, will actually compact your soil more because they're pushing into it and compacting it. So if you need to aerate, it's much better to get one that pulls the plugs out because that's not compacting your soil. Does that make sense? Mm-hmm. Do I have anything else to say about compaction? Yeah, because compaction, obviously, you have less oxygen, you have less water, so you don't have as many bacteria, you don't have as many fungi that are beneficial in your soil. It just has all kinds of side effects there. Okay, salt. I found this really cool graphic here that kind of explains it. So you got your healthy soil, you got a saline soil, which means it has salts in it, but not necessarily sodium salts, just salts like potassium chloride. Anything that's like that can be a salt. So it doesn't necessarily mean it's sodium. But all the way to the right, the ones that have sodium in it are the worst. Not only can they, kill the microorganisms, but they can actually mess up the soil structure. I didn't put structure in here as a slide. The structure is basically the best soils are kind of granular. They're grainy. You can hold them in your hands and do this. But you have soils that when you get too much sodium in there, it can create these big blocks or these big prisms of soil and it can crack. As you can see in the picture here, it's cracked. You know, soil's cracking and it's crusty and everything, and that's really bad. So not only do we have people putting too much salt on their soil, if you're irrigating with salty water at all, that's really bad for your soil. And then the worst thing that's happening now in the world and in Delaware is with sea level rise, that salt water comes in and it'll inundate and it'll make our soil salty and then things won't grow. So you don't want to add salt to your soil. Tilling. So this was a image I found to try to explain it because it's kind of counterintuitive. People think that tilling is good because it'll help break up your soil, but tilling is actually old-fashioned tilling or using like a rototiller or something like that is actually bad for your soil because it messes up it also messes up the structure of the soil. So you got this picture here, this one's been left alone. Plant roots are growing, the soil is nice and rich and dark because there's lots of earthworms and things that are making tunnels and all this kind of stuff. You start tilling, you mess up all those paths. And your soil ends up getting more compacted and it destroys the structure and the organic matter of the soil is reduced when you do this. So it's kind of counterintuitive. You have to kind of think backwards when you talk about it. And I got into an argument with somebody about that and they were like, tilling is good because it gives those microbes air and stuff. Well, the microbes are getting air from all the tunneling things and the roots growing and everything else. You mess up that, then they're not getting air. So this is just a kind of a visual that I like that shows a comparison of left alone soil to something that has just minimal tillage. Like sometimes you just have to, you're planting a field, you just have to break it up a little bit, but there's ways to do it. Like you can only just till right where you're planting a row of seeds instead of the whole thing. So just minimize it. And that's better than just tilling up the whole thing like this lady, obviously not in Delaware, is doing.
So Debbie, if you were, say, creating a new garden
Mhm.
space from your yard, and it's never been that before, right? It's been just yard or whatever. So how would you start that, and how would you get it to be a garden area? Because you couldn't just dig up whatever is there, like grass or whatever, and plant some. You know what I'm saying?
I think probably the most modern way is to put things on top of it. A lot of people will start by putting cardboard down in the area, putting compost or good soil on top of it and just building it up instead of digging down.
I've done about 3 new gardens that way, right on top of the grass. You have to wait about a season.
Okay, so you gotta be a little proactive and that's nice.
Does that make sense?
Yeah, it does. I've heard of that and I didn't. Okay.
That's my kind of question, right? If you're building a new bed and you're building it up, aren't you gonna need to water it more since it's kind of up in the air?
Actually, I've had better luck. Like, so say when I first moved to Delaware in 1995, I had a garden and I had tomatoes and I kept getting blossom end rot because the water table was so high, the soil was too soggy. So I actually get better results in a raised bed because it drains better. So there's, it's all a balance. You gotta have drainage, but you also need water. So you might have to water it more when it's dry, but when it's wet, you don't have to worry about it as much. So everything's a balance.
If rototilling is a negative, then what about the farmer who uses the plow? It does the same thing.
Yeah, there's been a push to get away from that. And like I said, they have machines, farm equipment now that can just plow one little road right where they're going to plant the plants and leave everything to the sides of it alone.
Oh,
There's a documentary called Just the Ground.
Is there?
Yeah, it's been on Netflix. I don't know if it's still on, but it's all about that, like trying to change big farming because they're basically that last picture is what they're growing on, cracked soil.
Yeah. So it's like, when you know better, do better. That's what I always say. Like I did things a long time ago that I would never do now because I just didn't know any better. So the whole thing is to learn and educate people. That's what we're trying to do so that once you know what science and research shows is a better way of doing it, that you don't go back to doing it, you know, the way that grandma and grandpa did, because they didn't know. They, not that they were bad, they just didn't know any different. Does that make sense?
Yeah.
What about the depth of tilling? Like, you said less tilling is better. By less, do you mean more shallow? You know, just to
Depends on
break
what you're
up the
doing. Like if you're, are you a farmer or are you a gardener?
gardener.
Why do you need to till it all?
Cause it's easier.
See, I mean,
Easier than getting.
I mean, you can just, if you're just doing a small garden, you can just dig a hole where you're gonna put that plant and put it in there. And then if you have put, you know, some kind of organic matter, whether it's fresh or whatever, around it, that will work its way in and you'll be good. But you don't need to do that.
And you had also said, I meant to raise this question before, about cover crops. I don't do cover crops on my garden, but I do mulch the leaves and I spread them out.
That's good. Yeah, that's good. Your soil is covered, it's protected.
Okay.
Do you have to mulch them or you just throw them in there like leaves?
You can throw them in there. We're gonna get to that. That's one of the other
Okay.
slides. But but yeah, they're either way. The thing about mulching leaves and stuff is, it's not for your soil, but for a lot of the, insects hibernate over the winter in the leaves. So when you chop them all up, you're potentially killing a lot of beneficial insects. So. I have a picture for that too. So, pesticides, this is another graphic I found. Sorry, it's a little blurry because that's what I found, but, so you put pesticides in your soil and you kill the life in the soil. It's like a chain reaction. You know, it's like you kill the life and then you don't have enough organic matter because that life is producing, you know, they're peeing and pooping in your soil and making it better. And they're eating bad things and they're doing all this stuff. So when you kill those, I mean, I have neighbors who just have companies come out and they just dump pesticides all over their yard, and I can't watch because it makes me cry. But it's, you want to have beneficial insects, so you don't want to dump pesticides all over everything. So there's just you know, it cuts down your you know, your biodiversity, all your different things in there. Also, if your water table is high, which we're also going to talk about, that stuff can go right through, right into your water and come out in your well. You know, my well is pretty deep, fortunately, but you know that it can be a problem. And then I don't know what the UV ray thing is on that. Okay, over irrigation. So again, when you have too much water in your soil, you don't have enough oxygen for the plants, which is bad. So you don't want your soil to be over irrigated to the point where it's soggy all the time. Rain, you can't do anything about. I mean, I have an irrigation system, but it's been in my property for 12 years. But I know things now that I didn't know 12 years ago. So if I was building a house right now, I probably wouldn't get an irrigation system. But my irrigation system is connected to, it's like super smart. It's connected to Wi-Fi. It has a seasonal adjust. So when we're having a cool day or something, it'll water less. It has a rain meter. So if it rains, it'll know it doesn't need to irrigate, so it'll turn off. So that's really cool. I know it's gonna be, I know it's kind of fancy, but you know, I don't want it to over irrigate. We do ours minimally. We do our irrigation maybe like 3 times a week. Like I said, my neighbors are out there doing it 3 times a day. And they're also doing it in the middle of the day, which is bad for the soil because, well, it's bad for a lot of things because for one, a lot of that water, if it's hot, it's evaporating. It's spraying out there and it's evaporating before it even hits the ground. So the best time to water is early in the morning. If you do it at night, then that water sits there all day and it can promote, you know, different things growing in your grass that you don't want there, like funguses and things that are bad. But if you do it early in the morning before the sun's hitting it, it's the best time to do it.
Yeah, going back to the pesticide thing, have you read anything, about how neem would affect those bacteria and beneficials going into the soil as opposed to typical?
You put neem I usually, if I have to use neem, I usually just put it right on the leaves of the plant.
Right, yeah.
So not on the soil. But what neem is it's a chemical, but it's organic because it comes from the neem palm tree. So that's why it's organic.
Yeah.
But the cool thing about neem is it kills the insects that eat it. So if you have it if you spray it, if your insect is eating this leaf of this plant, you spray it right on the leaves. And then when the insect eats it, then it ingests that and it kills it. But it can be bad for other things. You don't want to spray it like when bees are out active, because if it gets on them, it's not going to be good for them. So, there's a balancing act, like I said, I try to avoid using anything organic or not on my garden unless I absolutely have to. So I found that once I put up bird feeders, I don't have a problem with Japanese beetles anymore. Because the grubs. So there's a balancing act, of course I got, other things that make life difficult when you have birds, not to mention I'm spending like $100 every couple of weeks at Tractor Supply for bird feed because they eat it up as soon as I put it out there. But I don't have to use pesticides because, that was one of the main things I had a problem with was Japanese beetles in my cherry tree. But they all of a sudden put up the bird feeders and they're gone, like a miracle.
Nice.
So another thing about the irrigation, there's a water table under the ground, right? And a lot of your wells go into that, whatever. So when you water a lot, that's going to make the water come up from above and it's going to get higher and closer to the surface of the soil. Well, what that means for your plants is that they're like, oh, this is cool. This water's easy. I don't have to work as hard. I don't have to put my roots out as far, I can just float along here and just take this water. But then what happens when there's a drought? Your roots are way short up here because they're spoiled from having that water so close. And then they can't reach the water and they die. But if you have plants with deeper roots and that's a whole nother thing is native plants tend to have deeper roots and they need less water and less irrigation because they can get to it. They can put their roots down there and get to it. If you put any chemicals on there, you over irrigate it, like I said before, it can get all the way down into the water table. So you don't want to be drinking those things that, I won't drink my tap water. I'm bad. I wish I had another way of doing it rather than using plastic bottles because I hate doing that. But, I don't do it when I'm away from my house, but my water is awful. It tastes like, it smells like sulfur.
Because nowadays you have to worry about plastic in your food.
Right, yeah, I know. It's always something. As I said, remember when water bottles came out and it was like the best thing ever and everybody promoted it until they found out that there was all this, plastic. It's like, it goes back and forth. Something that used to be great is now not great anymore. So, but I'm trying when I have a house in Canada and our Canada house is fed by a spring. So the water comes directly out of the ground, out of a spring. And it's like buying spring water in the stores. It tastes great. So we don't buy plastic there, but at my house in Delaware, where it comes out of my well, and especially if we go to Canada and we come back and you turn the water on, that rotten egg smell of the sulfur is really bad. So I'm like, I'm not drinking that. So the other thing is when your soil is wet, it's easier for it to compact. So you should never, this is what I meant to say when we talked about compaction. You should try to avoid walking on soil when it's wet because that will compact it more. If you have to walk on it, remember what we said about spreading out the weight? If you have a nice wide board, you can lay the board down. Like if you need to plant something, you can lay the board down. And if you walk along the board, that actually spreads out your weight. So it reduces your compaction. So that's a cool trick that you can use.
So this summer, we got no rain. So how often would you water? Like this past summer, when we had no rain, once a week or?
It's going to depend on what you're growing and how well established your plants are.
Yeah.
So if they look like they're needing it, if they look like they're wilting and they needing water, then you would water them. You just have to kind of play it by ear. If you're growing native plants or even like they have native grasses now, lawn grasses that require less water. So it's going to depend. If you're using, some kind of grass that's really needs a lot of water, then you're going to have to water. So, That's why I said my irrigation system is smart, like it takes all that into consideration. It looks at the it gets connected to the Wi-Fi, so it knows when it needs to be watered, so I don't have to think about it. But I'm trying to, we have a workshop coming up called Lose the Lawn. That's part of my plan, is I want to reduce my lawn and put some native plants in there. I just have to convince my husband. He's like, I said, and it has to have a, a border, so it looks like it's planned, not just gone wild. So he's like, well, make sure you make it like straight lines because it's easier to mow around them.
I get it. It's compromise.
So, fertilization, really bad for your soil to over fertilize and really bad for the environment. So, if you put too much nitrogen fertilizers on your soil, okay, and like I said, the soil test doesn't measure that. Okay, but they're going to tell you need nitrogen. If you use an organic one, you're safer because it's more likely to break down slowly. If you use an inorganic one, like they'll tell you to use ammonium nitrate or urea. Urea is slower to break down than ammonium nitrate. If you put ammonium nitrate on there and it rains and your plants can't use it, or even if it doesn't get into the soil, it'll wash away. So if it's going to rain, it's probably better to see if you can work that into the soil a little bit, not till, but scrape it into the soil so it doesn't have as much chance of getting away. Because it'll go into the water and algae will grow. And what happens when algae grows? Algae is a plant, so it's using the oxygen that's in the water. Okay, so there's fish down there, so the fish get deprived of the oxygen and they die. So, and then you got dead fish everywhere, which is even worse. Phosphorus is even worse than nitrogen because phosphorus can cause not only algal blooms, but cyanobacteria. So cyanobacteria is if you swim in water that has that in that, you can get sick. People have gotten sick from swimming in lakes that are polluted with phosphorus runoff. So that's why we say if you don't need phosphorus, don't put it on there because you could end up killing somebody that got poisoned by swimming in a water that was polluted. I don't swim in lakes anymore. I did when I was a kid, and now I'm like, I don't even like swimming in the oceans. So anyway, yeah, this is also, I gave my daughter that crossword puzzle and she couldn't get this one, but she didn't see my presentation. But that's also on your puzzle. So you need to know the cyanobacteria is caused by too much phosphorus runoff. It grows, and it's also known as blue-green algae. So if you ever hear anybody talking about blue-green algae, it's not actually an algae, it's a bacteria. That's just what they call it. I guess because it looks like algae and it's blue-green. Anyway, if you're spending all this money on fertilizers, if you test your soil and you don't need it, then you shouldn't use it because you're wasting your money and you're polluting. And all of these things, too much of any of this in the soil is bad for the soil, the microorganisms, and too much can be bad for the plants. You ever heard that too much nitrogen, can turn your grass brown? So too much is not a good thing. Okay, last thing here is the leaf. We talked about the leaves. So not only do leaves break down, they're broken down by all the microbes and all the organisms. And they're going to chew them into smaller pieces. The biggest organisms will chew them into some certain size pieces. Then the smaller organisms will come in until eventually you get down to the very smallest, like the bacteria, and they completely decompose. It takes longer if you don't chop them up, but this is I like this little guy. This is a hummingbird clearwing moth, which is found all over the country, but they overwinter in the leaves. So when you chop up your leaves, you're killing this beautiful little insect. So I think that was the resource list. You guys have that on your back page. If you're interested, it's just some of the places that I got some of the information from. And also want to mention that we do have workshops. You guys could have picked up a brochure. We have spring session coming up. We'll have a summer brochure coming out, and then we'll have fall and winter. So every season we have a new set of workshops. Garden advice program, we started a couple of years ago. If you need a master gardener to come out to your house and look at things, there's $100 charge. They don't do any work. Some people think that we're going to come out and fix their garden. We come out and look at stuff. We can identify plants. We can give advice if you have something like a tree that's suffering, or you want advice on where's the best place to build a garden, all different things. A team will come out and advise you. So you can apply for that online at this website. If you want to get to the website really quickly, I can take a picture of that code and it will take you right there. We have a helpline. If you have questions, you can call the helpline number. Starts in April, so April through October. And this year we're having a new class of Master Gardeners of 2025 already, every odd year. So every other year we have a new class. So if you're interested in becoming one of us, a Master Gardener, you can go also to that website and get more information about that. Yes.
There is an online question. Will Zoom attendees receive handouts?
I sent the handouts to everybody who registered as Zoom. Did they come?
I don't know. This is just.
Mary Marciano.
If you signed up for Zoom, if you registered as Zoom, I sent them to you. They're attachments to the
She
email.
is on this.
Okay, so they should have been attached.
It could be Mary Downs. I'm not sure. It just says Mary.
Okay. They're attached to the emails. If you signed up for in-person, I didn't send them to you. If you signed up for in-person, but you decided to switch and come by Zoom, just let me know. Just send an email and ask for them.
Susan McCarthy said that. She said she wasn't registered for Zoom, but she was registered for here.
Okay, well, I won't remember. So Susan, if you can send an email and remind me to send you those, I can do that. No problem. So if you're interested in becoming Master Gardener, you can get information there. I believe we also had a brochure out there. So it basically is from September to November, Mondays and Wednesdays from 9
to
12:30. 9 to 12:30.
Something like that.
Yeah. And some of it's done here, some of it's done in Sussex County. Some of it done in Newcastle.
In Newcastle County, so all three counties will train at the same time, but
Sure.
Kent and Sussex, we train together at the same location.
Yeah.
Yep.
And some of it's done online, some of it's done on Zoom, right?
Yes.
Yeah, 2 questions. Regarding the compaction and thinking of the farmers and their big fields, their big heavy equipment. If they keep plowing year after year and it gets more compacted, they too, then is that reducing the yield and the quantity and the quality
Oh, yeah.
of the crops?
Yes, definitely. And as part of the class, I took another thing too for doing that is if you get a drought, you ever heard about the Dust Bowl, right? Mm-hmm. There's a really good documentary on YouTube about that and how they didn't know what they were doing and they overdid it and they left their fields bare and the dust came in and it blew all their soil away. So, it's like when you know better, you do better. But a lot of farmers are changing their ways. And a lot of them are using cover crops. I've talked to a lot of farmers in Delaware that say, hey, they're using cover crops because eventually they'll find out it saves them money. Because that's all about, profits. They want to make profit. That's their business. So they're not going to do anything that's not going to save them money. So, it's our job. Part of what we do is show people things that they can do that's better for their soil and better for the environment. And also will make them more money. Maybe not at the day one, but over time.
So they're using the cover crops, but then they're still going out the next spring and tilling it all under, right?
Not
necessarily.
There's a lot in Delaware that are now doing the no-till. It's a practice. It's pretty much, it's
Mm-hmm.
in use.
And if so, they could leave, they could just till right along that row where they're going to plant and leave the part in between. Or they could cut the cover crop down and leave it lay on the soil without tilling it in.
Then my other question is, 2 of my neighbors have their lawn sprayed and the guy across the street has his lawn sprayed. So I'm wondering, does anybody know how far, I guess maybe it depends how much they put or the type of herbicide that they use. how far it travels underground?
Underground. It's, yeah, it's
Like
gonna
a
depend
runoff.
on a lot of things. It's gonna depend on the weather.
How much rain you get.
Yeah, and you know, the soil, like if your soil, depending on how much pore spaces, how airy your soil is, it can travel faster. Things can travel faster through airier soil. If your soil is sandy, things move faster and deeper through sandy soil. If water hits a clay soil, it kind of tends to just go out like this. And when it hits a sandy soil, it's gonna go, since sand drains so much faster, it'll go straight down. So it just depends on a lot of things. What you want to make sure is that they're not doing it on a windy day.
Yeah.
And that's the problem I have, is my next door neighbors people come out and spray and it's windy. And I have signs, you know, I'm like, my garden is right there and they're spraying stuff right next to my garden on a windy day.
I've gotten in arguments with them.
Yeah.
I mean, they say it's not windy. I'm like, it's windy.
Yeah.
Yeah, they're probably
It's a
trying to
problem.
get numbers done, you don't
Yes.
have many, right?
Yeah, it's so many times.
You know, and the biggest thing is, like I said, you know, a lot of people just don't know better. But there's people out there that don't want to know better. And that's the biggest problem. Because we've had neighbors, you know, I mean, they were doing the mosquito spray. And the mosquito spray kills a lot more than mosquitoes. And my husband mentioned that to him and he said, I don't care. So what do? You know, I mean, I don't know what to say about that. But all we can do is tell people the advantages of doing different things and, you know, and hope some of it sticks. My next door neighbor has landscapers and they have the mulch volcanoes around their trees, the big piles of mulch coming up there.
Oh, yes.
And the tree, yeah, and the tree that's right next to my lawn, I know it's dead because it still has all the brown leaves on it. The leaves never fell off; they just died. So, and they have this big mulch volcano. It's like they're, you know, they had their trees staked up for like 5 years when they planted them. They didn't take the stakes off, and that makes the tree weak because it needs to develop strength. Yeah, it's like, you know, I mean, it's like 25-year-old still riding his bike with training wheels. You know, it's like you don't ever learn to be strong enough if you don't have that flexibility. Do you guys have any other questions?
There was one other thing, a comment in the chat. One suggestion regarding trying to change the pH of your soil. Sometimes the best thing you can do is plant plants that like the pH you already have. Trying to change pH, as Debbie pointed out, takes a very long time.
Yep. And that's true. And that's one of the things about native plants. Native plants like soil a little bit more acidic. So if your soil is acidic and you're like, I'm trying to plant these, you know, exotic plants that like the pH of 8, give up. Plant native plants and you're a lot less stressful. You know, I'm all into low stress. I like to plant things that are going to do well to start with. So that's another thing. You can have your soil tested and you can do the opposite thing. Like she said, instead of trying to change it, you're going to say what grows well in this pH. But in general, if you're doing a vegetable garden, you know, 6.5, if your pH is, you know, we saw that little chart, if your pH is much lower or much higher and you don't want to change it, then you can. Like you got a low pH, there's a lot of things that do well in low pH, like blueberries. Blueberries don't like high pH. So any more questions? That's Coco. I decided to put her on my slide. I miss her.
Of those 3 books, which is the least chemistry? Or which one has?
I have
chemistry?
only browsed these. I haven't read them, but these are more about like how to fix your soil. This one does have a lot of chemistry in it, but you don't have to read it all. It's pretty well explained. There's parts of this that, you know, like any book, there's you can read something on one page and it contradicts it on the next page. So you got to take that all with a grain of salt. I think this book was originally published by the Mother Earth magazine people. And so it could use a little bit of editing.
What's it called?
Soil Science for Gardeners. I mean, it has some, you know, like a lot of these books that you buy that I find a lot of garden books have a lot of typo errors and grammatical errors and they're a little rough, but this one is a little rough. It's not too bad, but this has really good information. But if you read it, you may find that it contradicts itself in 2 different chapters, almost like they were written by 2 people with 2 different opinions. So you know, you just gotta process it all and do what you think is the right thing to do. So.